If you've been following tech at all, you know the story, right? It's a full-blown arms race. We're all holding our breath for GPT-6, watching these massive, city-sized GPU clusters get built, and now people are seriously talking about needing dedicated nuclear reactors just to power the next generation of AI. The assumption is just baked in. Bigger is always better. More data, more parameters, more power. But what if that entire assumption is just wrong?
What if we're not actually building a faster rocket ship to the future? What if we're just adding these complicated little patches, these epicycles, to a model that's fundamentally broken at its core?
Okay, so let's unpack this with a fantastic historical analogy. For something like 1,500 years, Ptolemy's model of the universe, the one with the Earth smack in the middle, was considered absolute fact. But when his observations of the planets didn't quite fit the theory, when they wobbled, he didn't question the theory itself. Nope. He just invented epicycles, these little circles spinning on top of the big circles, to explain away the errors. He just kept adding complexity to make reality fit his flawed idea.
And that is exactly the argument being made about AI today. Our modern AI has its own flawed center of the universe, statistical next word prediction. It's just guessing what word comes next based on patterns. So when these models get things wrong or fail at basic logic, we don't fix that core mechanic. We just add our own digital epicycles. We throw more data at it, add billions more parameters, invent fancier ways of prompting it, all to patch a system that might just be fundamentally disconnected from reality.
And this whole approach, this constant patching and layering, is driving us straight into two massive unsustainable crises. And they're pushing this entire field to a breaking point.
So, first up, we are slamming into a thermodynamic wall, a wall of energy. As of early 2026, the power being eaten up by AI data centers around the world hit a frankly staggering 61.8 gigawatts.
To really put that number into perspective for you, that's the entire electrical grid of a G7 nation. That's all of Italy. And the scary part? It's growing at 22% every single year. We are building an energy-sucking machine that's on par with major industrial economies, and you just can't sustain that.
So why is it so ridiculously power-hungry? Well, here's a great way to think about it. It's called the cocktail party problem. Imagine you're at a party, and to say just one new word, you have to stop and mentally replay every single word everyone else in the room has said all night long. That's literally what these AI models are doing. To generate one new token, they have to reprocess and recalculate the relationship between everything that came before it. It's not linear. If you double the conversation, the work doesn't double, it quadruples. It's an explosively inefficient way to think.
The second crisis is all about trust. Now, this equation might look a little intimidating, but the idea behind it is incredibly simple. The C stands for the AI's context, basically its internal brain. The R stands for reality, the real world. And what this equation says is that the connection, the information shared between them, is pretty much zero. The AI is basically a submarine with no windows, trying to navigate the ocean floor using nothing but a library of old, out-of-date maps. It has no live feed, no connection to what's actually happening outside.
And what happens when you operate that way? Well, because it's just a really sophisticated guesser, just completing patterns from its old maps, it just makes stuff up, it hallucinates. And it does so with incredible confidence. Even with all our tweaks and patches, the error rates for simple factual questions can be as high as 30%. I mean, come on, that's not good enough for a calculator, let alone an AI we're supposed to trust with medicine or finance or law.
Okay, so if that's the problem, what's the solution? We can't just keep adding epicycles, right? We need our own Copernican revolution. We have to change the center of our universe. And the proposed solution is to puncture that black box, to open a window and create a direct, verifiable connection to the real world.
And this right here, this is the aha moment. On the left, you've got that closed system, our submarine with no windows, just guessing. But on the right, this topological puncture acts like a periscope. It lets real-world data that's been cryptographically fingerprinted to prove it's authentic, like a specific lab result or a GPS coordinate, be injected directly into the model's reasoning process. It grounds the AI's predictions in actual verifiable facts.
And this unlocks something absolutely crucial. The system gains a brand new skill: active refusal. If its confidence in an answer is low, it doesn't have to just roll the dice and make something up anymore. Instead of hallucinating, it can actually stop, say, "I'm not sure," and then go query a trusted external source for the real answer. It finally gains the ability to say, "I don't know, let me go check."
So what makes all of this possible? It comes down to a totally new kind of building block:
We're getting rid of the old statistical token and replacing it with a verifiable unit of meaning called a tokum.
So how in the world does a token work? It uses this brilliant analogy from computer networking. Think about it this way. Every single concept gets two addresses. The first one is like an IP address or a website name. It's the global, logical meaning of a concept, like pneumonia. The second address is like a physical MAC address. It anchors that abstract concept to a specific real-world measurement, like one particular chest X-ray from a specific hospital taken at a specific time. One part provides the meaning, the other provides the proof.
So a tokum is what fuses those two addresses together. It's a cryptographic hash, which is really just a fancy way of saying a unique, unforgeable digital fingerprint that permanently locks the abstract idea to the concrete verified fact. In this new kind of model, every single parameter, every piece of its brain is a tokum, which means everything it knows is verifiable, auditable, and actually grounded in reality.
And the results of building this way are just profound. Instead of that incredibly slow, power-hungry cocktail party search, the AI can now look up a fact instantly, like you'd look up a word in a dictionary. It doesn't need this massive, dense brain where every neuron is connected to every other one. Instead, it uses a hyper-efficient brain that's almost entirely empty space, and it only activates the exact facts it needs for a query. The whole system makes a fundamental shift from slow, probabilistic guessing to fast, deterministic knowing.
So what we're talking about here isn't just a technical upgrade. This is a fundamental redefinition of what we even mean when we say the word intelligence. The old way of thinking, on the left, treats intelligence like an asset, like a treasure you hoard in a locked box, and you measure its worth by how many billions of parameters you've collected. The new paradigm sees intelligence as a flow, a dynamic ability to reduce uncertainty by taking verified measurements from the real world. And the argument is, this shift isn't just a nice idea. It's thermodynamically inevitable. That energy crisis we talked about, it's going to force us to do this.
And the practical impact on energy it's almost hard to believe. Just look at this chart. For a single thought, a single inference, the old dense transformer on the left burns 100,000 watts. The new, sparse, grounded architecture on the right, 1 watt. That's 100,000 times efficiency gain. That is literally the difference between needing a nuclear power plant and running on a cell phone battery.
So how does this actually get us to zero hallucination? Look, it's not about the AI suddenly becoming all-knowing. It's about it becoming honest. When the AI is uncertain about a fact, it simply refuses to guess. It triggers that active refusal, queries a real source like a medical database, gets a verified fact back with a cryptographic receipt, and then gives you a grounded, auditable answer. On matters of verifiable fact, it is structurally incapable of lying.
Which brings us to this final, pretty provocative question. For the last decade, the entire AI industry has been worshiping at the altar of scale, betting trillions of dollars that more is more. But what if intelligence isn't about the size of the brain, but about its connection to reality? If that's true, have we been building these massive, energy-devouring cathedrals to the wrong god this entire time?